A single-cylinder 155 cubic centimeters engine, yet it features variable valve actuation. Today, let's tear down the Yamaha NMAX 155. Its transmission case has a high-flow air intake. And it even includes a filter element. The outer cover of this transmission case also features dampening foam. With domestic and joint venture scooters getting cheaper and cheaper, this Yamaha NMAX constantly gets pulled into soul-searching debates regarding its value. However, its price remains rock solid. Even its resale value in the second-hand market is very strong. Let's look at its front drive. It uses parts from Fuji, Japan. There's an FCC mark here. Now let's check out its clutch assembly. Since the front uses Fuji, the rear definitely does too. Here is also an FCC logo. Take a look, it's a 3-shoe clutch. The belt is from Mitsubishi, Japan. Yamaha scooters have always used this brand. Let's check out the front Variator rollers. Mainly to weigh them. 13.15 grams. Actually, we don't really need to worry about its stock weight, because there are so many aftermarket tuning shops for the NMAX. What I'm removing now is the actuator unit of its variable valve system. Let me show it to you first. Later, I'll take off the cylinder head to explain how it actually works. It is mounted on the cylinder head cover, not directly on the cylinder head itself. Look over here. There's something inside the middle, which is a shaft like this. This actuator is responsible for pushing this shaft. And this shaft then pushes the pin on the rocker arm. I will demonstrate the whole system as a whole later. Next is the water pump. Its water pump is also driven by the camshaft. Speaking of the camshaft, I need to explain something here. The profile design of a camshaft lobe is always a trade-off. You can't have it both ways. Either you design it for strong low-end torque, or you optimize it for high RPM power. How can you achieve both? That's how variable valve actuation was born. Let's look at its chain tensioner first. It's a hydraulic tensioner. The advantage is that it offers great protection for the timing chain. The disadvantage, however, is that it makes the engine a bit noisy. But the pros outweigh the cons. Moving on to the timing sprocket. There is a decompression valve on top. It relieves resistance the next time the engine starts. Regarding decompression valves, some use manual decompression. If I remember correctly, it was on the Yamaha Chappie. I don't know how many people still remember that bike. It had a manual decompression mechanism, operated by a cable. Alright, let's look at the cylinder head structure first. Yamaha's variable valve technology is called VVA. As you can see, its exhaust rocker arm is just a standard rocker arm. However, it has two intake rocker arms. These two rocker arms, whether VVA is engaged or not, do not work at the same time. Basically, when you're working, I'm not working kind of thing, below 6,000 revolutions per minute, the rocker arm on the left is the one working. The camshaft lobe corresponding to this rocker arm has a low lift profile. In case it's confusing, let me take the camshaft out first. A VVA camshaft has 3 lobes. The two on the left are both intake lobes. Before VVA engages, the leftmost lobe is used. After it engages, the middle lobe is used. To put it simply, this middle lobe is clearly wider, while the leftmost lobe is clearly narrower. The wider one provides more valve lift for greater air intake, and the narrower one gives less air intake. Let's get back to the rocker arms. Below 6,000 revolutions per minute, the left rocker arm works, which is the low lift mode. At this time, the right rocker arm just follows the camshaft idly, under the tension of its spring. It moves along with the other one, but it has no actual control. It cannot actuate the valves right now. The valves are still controlled by the left rocker arm. You can see it clearly on the screen. Once the RPM exceeds 6,000, the actuator unit mentioned earlier will push the pin inside the head cover, which then pushes right where my hand is pressing, locking the right rocker arm in line. At this point, the right rocker arm takes over valve control, while the left rocker arm is bypassed. As I just said, the high lift lobe on the right is wider, and the left one is narrower. So when the right rocker arm is working, the left rocker arm can no longer touch the camshaft lobe. It is lifted clear by the wider lobe. In other words, the left rocker arm floats above the camshaft, just moving idly along with the right rocker arm, serving no control purpose whatsoever. This completes the camshaft's transition from low lift to high lift profile. This is how Yamaha's VVA system works. Next, let's keep tearing it down to look at the cylinder block. The NMAX 155 uses a DiASil cylinder. This thing has excellent heat dissipation and a low friction coefficient. Domestic manufacturers haven't reverse engineered it successfully yet. To match its performance, they have to use more expensive ceramic cylinders. Now let's look at the piston. It features a forged piston, which is a lightweight design. Using a forged piston in the 150 cubic centimeters class is actually quite rare. Oh, right, I forgot to highlight the main benefit of VVA. I briefly mentioned it at the beginning. A standard camshaft lobe design either gives you strong low-end torque or high RPM power. You can't have both. Or rather, it's always a compromise. VVA solves this exact issue with two valve profiles, one for low RPM and one for high RPM. It balances fuel economy and low emissions. The stator/magneto is imported from Japan. It uses a smart motor generator starter system, so there's no conventional starter motor. The Yamaha NMAX has been out for 15 years, and even until now, no domestic brands have cloned this engine. They are all cloning Honda's 150 cubic centimeters or 160 cubic centimeters engines instead. Even Old Tao praised the NMAX 155, saying it uses high-quality materials and complex technology. That's absolutely true. The DiASil cylinder still cannot be manufactured domestically. VVA hardware might be easy to replicate, but the fine-tuning is extremely difficult. Look at that, 15 years later. Just this year, did we finally see variable valve lift technology appear on a domestic scooter engine. Lift profile. Let's check out the crankshaft bearings. It uses specially heat-treated NTN bearings. It also utilizes offset cylinder technology. The offset cylinder design is also meant to reduce friction and improve fuel efficiency. Let's look at the timing chain. The timing chain is made by DiD, Japan. Since you've watched this far? If you like the video, please give us a thumbs up. Now let's examine the gearbox, focusing mainly on the bearings. I found CNU bearings inside this imported bike. This one is a P6 grade bearing with C3 clearance. This other one is also P6 grade. Let's look over here. It seems CNU has already established its supply chain domestically. This side also uses a CNU P6 grade bearing. Alright, that's the complete teardown. Even though this is a product designed 15 years ago, it is still considered highly advanced compared to current domestic standards. DiASil cylinder, forged piston, VVA variable valve lift, and offset cylinder. There is also a YAMT CVT version that hasn't been imported yet, which is even more advanced. Beyond the implementation of these technologies, even the choice of base materials is top tier for this category. Of course, it's not just about the engine. The chassis performance of the NMAX is also excellent. At this point, some people will definitely say, well, look at its price tag. True, but while looking at its retail price, you also have to look at its value retention. Its second-hand price remains very high. So, you can't just complain about its high upfront cost forever, since it also fetches a high price when you resell it. Relatively speaking, the total cost of ownership isn't actually that high. Alright, that's it for this video. Thank you all for watching.